thank you all so much. Just to let you know, it is hot in this room. Thank you very much for holding out till the end. We had over 700 registrations for this event. I find that amazing. Just the sheer amount. We've been talking about the need for increased awareness of the need for post-quantum cryptography and migration to quantum safe security. But what is absolutely clear is the kind of response we're getting to this kind of challenge, and the amount of interest in building awareness, whether that be from the supplier side, the telco side, and others. Unfortunately, we couldn't fit all 700 people in this room. Fortunately, possibly, there is even an overflow room outside, but it is being live streamed, and it will be recorded and put up again in various fora. So please keep a lookout for that. What I'd love to do is get my panelists to introduce maybe a brief word. As Laurie said, Kelly Richdale, I come from Sandbox AQ. There is actually another Sandbox somewhere in the one of the halls. We're a different one. We're AQ. The A stands for AI, the Q stands for quantum, and we specifically work on AI and quantum, solving hard problems for society, including in cryptographic management, which will be much of the discussion today as we negotiate the migration to post-quantum cryptography. I'm also a quantum fellow at the World Economic Forum, working with Seb and his team, and very pleased to be building up societal awareness and public policy awareness around the move towards a quantum economy. So Avesta, maybe starting with you, we'll do this, we'll jump around afterwards, but let's just go straight in a line for this first intros.
Sure, yeah, my name is Avesta Hojjati. I'm a VP of Engineering at Digicert. Digicert is a leading provider of digital trust. Most commonly, folks are knowing that as being a PKI. We are the largest PKI provider, both for public and private. And what I do at Digicert, at least for the past 7 years, has been breaking some of these PQC algorithms and building products on top of them. And that's because my background is basically breaking into systems. So I keep it very short.
Taylor.
All right. Hi, everyone. My name is Taylor Hartley. I am a security architect for Ericsson North America. In my role, I focus on emerging technologies or emerging threats, right? So that includes PQC and quantum, as well as AI. I'm typically U.S. government facing, but I make some room on my plate to be a part of GSMA's PQTN, where we've been working on these documents and having a good time doing so.
Diego Lopez, I'm a senior technology expert in Telefonica, and I'm leading a group that is working with, well, we call it technology exploration. I prefer to call it applied research. What we try is to identify opportunities that are a few years ahead, evaluate them, and try to assess the company about the evolution of the technology. And then among these things, well, you include AI, quantum technologies in general, not only cryptography. We are looking at security, and this is one of the aspects. And well, everything that has to do with crazy new architectures, including doing nasty things to 6G in the future. That's for another.
Ryuji.
Hello, everyone. I'm Ryuji Wakikawa from Softbank. I'm leading the research in the Softbank, and the Softbank is a mobile operators. And but like. We are also like doing the 6G
nasty stuff.
But as well as like we have like whole quantum like research, both computing, quantum computing, QKD and PQC, and these are mostly coming within 10 years or maybe sooner. And as operators, how we can deal with these technology? Maybe we will provide commercial services to customer, deliver the quantum computing. Or like we can provide a PQC for enterprise customer, or we can use the PQC in our network. So we are testing significantly on the PQC technology with the Sandbox, and did a lot of like a pilot program in Japan. Thank you.
So what I'd love to do today is go through some of the, ask the participants what your companies are doing, what your enterprises are doing in the world of PQC, talk about some of the technical challenges and even opportunities about the migration process, and then talk about some of the business opportunities, just to give you a flavor of what's to come. So Taylor, why don't we start with you? What's going on in Ericsson? What kind of work are you doing around PQC? And very importantly, what level is this happening on? I'd love to explore a tiny bit. You know, we heard earlier that this kind of migration, it's not enough for it to be at the CISO level. It's not a CISO only challenge. challenge. This is an enterprise-wide challenge. So what is going on at Ericsson?
Yeah, thank you. So at Ericsson, we've been tracking this quantum threat for quite a while, and our research department's been working on PQC. But in the U.S. specifically, we have a very strict timeline that's been put upon us to begin this migration to start in moving to PQC, right? So for me, over the last 18 months, what that's looked like is driving executive engagement. So if anyone needs basically the PowerPoint for PQC for Dummies, all right, I've given it 1,000,000 times, right? And the key thing to note, if anyone else is in a similar position, the question that you're probably going to get is this a standards thing or is this a technical thing? Because I think there's a connotation that this is just a standards thing and it's just going to work itself out, right? And the worry that there needs to be, a technology change or a bit more investment isn't quite there. So you really have to emphasize that and start driving that. All right, so after you take all the points that we mentioned here today and you gather executive engagement, from there you need to get your security team, your cryptography experts, any quantum experts you might have, and your strategy team. And from there you can start building out your roadmap and your plan, right? So we've gotten to that stage, and we're a global company too, so we also have to work on making sure that our internal messages align, especially across borders. All right, from there, now we have to have this cryptographic inventory, right? Raise your hand if you have a cryptographic inventory of everything in your company. Everything? Everything? Okay, right?
Some
Yeah.
items, yes.
So, yeah, exactly. So for a large company like ourselves, we also have to, create a clear scope. Right? How are we going to attack this? Is it going to be by customer, by product, a little bit of both, right? By country, right? Because every country is a bit different. And so, after that stage, also looking inside, what products do I already have? We have an Ericsson security manager that does a lot of these things, right? It does like a compliance scan, so it can check what protocols we're using, right? We manage our PKIs. We know where all those are, right? So how can we get all these tools that we already have together so we can become more crypto agile, right? So I think that's kind of where we are right now, is just leveraging the things we already have and pulling all our plans together.
Thank you. We'd love to go to Diego. You talked about crypto inventory for part of your network. So what is Telefonica doing? You mentioned a number of different projects, maybe 3 if I remember correctly.
Yeah, well, we're thinking about it during the other presentations. I was thinking that we are working in 4 lines. We had 2 running projects right now. One is very much connected with what Anita was presenting about the 2 basic protocols and the implications they have. We are working together with some research centers and other companies in experimenting what is being the evolution of TLS and IPsec, and how this evolution can be operationalized. Because for us, this is the great concern, is how you make it happen in our operations, and how we can. Well, Luke was mentioning about automating, and it's about how we can automate the whole thing. This is one thing. The second thing that we're doing, because it's important and it's a project that we started recently as well, is about measuring. For us, it's very important to meter, not only because, for example, just to give you an example, we are using, we are starting to use open source project that was somehow sponsored by AT&T about measuring the efficiency of the different PQC algorithms. Quite interesting. We are trying to go step ahead and trying to evaluate the implications this has, not only in terms of a map processor and how much time it takes, but about how much memory is consuming and how it behaves end-to-end when you have a full service. The third direction in which we are working, we're trying to explore the idea of how the hybridization with QKD as well. I mean, this is something that I know is something that some people here in the room will try to kill me, but we believe that at the end there will be a convergence. It's not that I hate you because you're a mathematician, I hate you more because you're a physicist, you are not going to provide end-to-end, you are only limited to this. We don't believe that's the case, and there are cases and applications that are important in both cases, and we have to explore it. among other things, because we are network operators and we're very used to heterogeneity. Heterogeneity is part of our DNA, so to say. And finally, we are trying to explore as well things that are related with delicate use cases. And one of the cases when Laurie and Luke were making the presentation is about lawful interception. And this is extremely delicate, but this is something that we have to consider ahead of time, because it's part of it's part of the key regulations that we are under, and this is something that we have to deal with as well. And we are working in those 4 directions mainly.
So very broad scope.
And in the meantime, we are trying to convince our operations to fill the crypto inventory, but that's another story.
Okay, we'll come back to some of the challenges about embarking on this quest. So Ryuji, you mentioned one of the projects that, again, for full disclosure, Sandbox AQ has been doing with Softbank. Maybe you can take us into that a bit and explain some of the results that you're seeing and
Yes.
where this is in your kind of journey about the different projects you want to do.
Okay, thank you. So as operators, actually, we did very similar things, like evaluations. That's a very like operators, way, to deal with the new technology. So we did also evaluation of the, implementations, like what's the impact to the memory, what's impact to the CPU, how the latency looks like. That's like where we are very good at. So we did the same evaluations and same evaluations. And I don't see like a much difficulty on deal with this technology. Vendor will provide a solution anyway. So applying to existing, infra, and operation-wise, it's not so difficult. The challenge is the migrations. How we migrate from here today to PQC ready. That's a challenge. For example, like we have 100,000 equipment in our network. Some are very hardware-based, which is impossible to upgrade the software. And how we upgrade the hardware-based equipment to the PQC level. And also, vendor use a lot of like a secret port for management, which we don't know, right? That's where we have some network failure a few years ago. That's because the vendor has some credential, like expire credential in the box, which we don't know. And then like a system never boot up, so whole entire network is failed. But we didn't know like they use the certificate for that management port, which vendor needs to know. So even like we have a very good way to have a security credential inventory, we need to really like trust the vendor, right? So we have a whole like system ready, but our network is so huge. And it's very impossible to really like understand where the security is applied, was applied, and need to be updated. So that's like a discovery project. We work with the Sandbox as well, but it's it's not really like so easy, And also like how we migrate. Like there are different ways to migrate to RSA to the PQC, and also like we did the test in the hybrid mode. And so I think another challenge is like communication to our IT divisions. They are part of their system. If we comes in, even in the Softbank, if I approach them like I want to test a security discovery program, what kind of security they use, they say no, because if we discover something, security vulnerability, they will be punished. So they don't want to support. They don't want to support us. So even for the inside the telecom, like there is a lot of like pushback from the IT division. They believe like their system is perfect, and but they are not so confident. That's most of the company actually, and also like for the many enterprise company we approach, there is an IT team. I should stop here.
Well, let's come back to some of the
Yeah.
external.
Are you sure
Ben.
you're not working for Telefonica? Because it's the same.
Yeah, I feel like there's a lot that you two could exchange afterwards.
Yeah.
But just before we move on to the others, at what level is the discovery program and the proof of concepts and pilots that you've been doing, at what level are these supported by the overall, by the board, by the CEO? What is it that's driving it inside your organization? Because there's obviously challenges about incentives, transparency, that are normal cultural human challenges associated with any kind of change management.
So for the discovery program experimentations, I didn't get any support from executive. So I didn't run the experimentations in the whole network. It's only like a part of like my divisions, right? So it's always challenging top the traffic. You know, it's IT hate that kind of things. Even for the research, they said no. And so that's a kind of like a, you know, how's the operator, you know, it's a very silo. And even IT doesn't really like, you know, monitor whole network, right? You know, some are like a mobile operational team, you know, sometimes the vendor help us to manage some of the network. So it's a kind of like a mess, right? And the coordinate agreement is impossible. So I think the easiest way to fix this situation is the regulations. You know, if the whole industry decided to move towards the PQC and the government or some regulatory, you know, define some rules for the operators, then we have to move. We have to do something, right, against that regulation. So that's what we are waiting for, actually.
I think that's really interesting because I think it was at Las Vegas at the GSMA conference in Las Vegas end of last year that there was an excellent survey done by the GSMA PQCN, and one of the results that came out very clearly was that the telcos are waiting for waiting for external regulatory environment to push them towards adoption of PQC and migration, as well as the standardization. And while the standards are hopefully happening sometime in the middle of this year, what we see is that the regulatory environment forcibly is lagging quite a bit. I'd love to come back to that point, but there was a lot of discussion on the vendors, and maybe Avesta, we can talk about, you're obviously taking this from the other perspective, so a challenge for the telcos is hopefully a business opportunity to some extent for Digicert. What do you see among your telco partners, clients, and what are the kind of POCs or pilots that you're doing inside Digicert to be able to manage this transition together with your partners?
Yeah, good question. So let me break our involvement in 3 different buckets. And I release that into being a standards, being product, and being consulting or advisory. I'm not sure how many of the folks over here actually have been involved with the NEST process. I exactly remember the date in 2016, August 20th. We started reviewing, 278 submissions, right? So 5 years down the road over here, we made some mistakes. Forget about Psych, that was released and was broken. As a cryptographer, that's very embarrassing. But moving forward to all the algorithms that we have had today, what we had to consider was the use cases that either being telco or financial sector has in mind. Between Falcon, Sphinx Plus, and Dilithium, they're all having different performances. Good news, performances are actually much better than RSA compared to classical algorithms. Bad news, they have a much larger key sizes, right? And that becomes a very big struggle, specifically for telco, right? If you have your stations that are not really able to handle those large key sizes, now you have to think differently. That brings me to the next side or bucket, which is the product side. Francis has an amazing slide talking about discovery, automation, and management. You're not able to automate anything if you're not able to discover it. So fantastic first bucket, go ahead and do the discovery. And what we have realized is, to the colleague from Softbank, some of the IT departments don't want to deploy new discovery solutions. So what we have done at Digicert is we integrate to already existing discovery solutions, and we apply some type of machine learning to figure out the assets that are going to be vulnerable to some of these quantum attacks. Not every single one of them are. For example, if you have a symmetric key, that is not impacted as highly as asymmetric encryption. Then we move to the automation side, and this is where kind of telco is more relevant here. And great guidance that was released by Lori and the team that they specifically are talking about automation. From the folks in the room, I'm not sure how many of you actually have gone through SHA-1 to SHA-256. I have been unfortunate to go through that, and it was a nightmare. Now,
Can you maybe have a show of hands? Who remembers that? Yes? directly involved?
It was a disaster, right?
Okay. How long did it take?
Oh my gosh, it's funny because even if you look, I guarantee you that there are specific corners that SHA-1 still exists, right? The wide internet scan tells you there is none, but in private sector, meaning inside the private environments, you can see some of those. So we have learned some of that lesson, but PQC is different. And again, I'm quoting Lori here. This is not that you're doing the migration once. Imagine January of last year, you were testing out what psych. 20 days into it, you had to switch to dilithium. And if you didn't have automation, well, that would have been the end of the career for that individual who chose the process. So automation plays a very big role. And in telco, this is where I would connect it to the advisory portion of it. We have done PKI for a very, very long time, right? So we do have the expertise that allows us to really see the environment and the use cases, either being embedded devices, being the BTSs, or being all the way to the software where you are going to utilize code signing to sign the firmware and so forth. So the advisory bucket of our leg at Digicert provides what we call quantum advisory services. We'll get in hand with the IT departments. We ask them about their environment. We do the scanning, or we run their own scanner. And then we come up with a strategy, which goes to your point of how we are connecting this to the CISOs, right? It's kind of an embarrassing story, but 4 years ago, I was talking to a CISO of a bank in Europe, and I asked him how many certificates they have on their laptop. And he said, maybe 60 or 70. With their permission, we ran a scan, and we found 680 certificates, right? So imagine that's a single CISO with a single laptop. And if you go to a telco and you ask them, like, you know, which department, which region. So at the end of the day, what it comes down for us is the proper strategy, building the solution based on what we are seeing with the telco specifically. And funny enough, we were just chatting about some terminologies this morning, and we came up with quantum G. Right? And instead of a 5G or 6G, now it's quantum G. It's the time for you to, exactly, to just build it into your, what we call security by design, you know.
So you heard it here first. Taylor, biggest challenge of the migration, both from the perspective of Ericsson and also from the partners to whom you're providing equipment?
Hardware. Right? We heard it here, right? Automation. So as we move more into digitization and virtualization, software is going to be just a far easier lift, right? I think, like, what is it? ML Kim's going to run pretty similar to Diffie-Hellman, right? So there's not going to be that much change. And yes, bigger key sizes, but I think a lot of use cases are already built to be able to handle larger key sizes. But hardware lacks the same crypto agility as software does. All right. Now, not all hardware, you're not going to have to uplift everything, right? Some hardware, you can patch it, right? Maybe once, maybe a couple times. We're calling this crypto flexible, maybe not agile, but a bit flexible. But the reality is there will have to be an uplift, and there will have to be modernization that happens to some hardware. And I think that might be the biggest challenge so far.
Are you talking IoT environment now? Are you talking the fact that some of the code is embedded in ASICs rather than crypto-flexible FPGAs, for example? Where's the crux of the problem on the hardware side?
Yes, some of those things I can't talk about. I'm sorry.
I'll cover a little bit of that, so just quickly, yeah. So,
what are you saying from the outside?
Yeah.
Thank you. Yeah.
So on embedded devices, usually we'll deal with memory-constrained devices, right? Some of these devices were completely fine with symmetric keys, and some of them that were utilizing TPM, Trust Platform Modular, for keeping the keys in there. Now, for something like dilithium, which has a massively large key size, you're actually not able to keep the size inside the key inside the memory. Basically, out of 100 kilobytes, you will take 96 kilobytes off of that. I know this is getting a little bit technical, but this is what we are dealing with. Again, to Softbank's comment here, some of these devices are so old that I can recall them. Good example, if you have a satellite in the outer orbit, can I recall the satellite down and put PQC on it? It's not possible now. I'm sure SpaceX is working on something close to that. But what we are trying to do here is to build a solution where hardware has been considered. And this is kind of unfortunate on the standard sides, right? Nest will come up with a list of algorithms, and Etsy will just, pass it and say this is great. They're not really considering the list of devices that we have to deal with, either from an IoT being a sensor or being a massive, supercomputer that sometimes actually doesn't have enough memory for crypto algorithms.
Would love to come back to that, but maybe Diego, you talked about some of the challenges also on the hardware, the crypto agility. What are you seeing in your very large and heterogeneous
definitely
network?
is this, and we are trying to. I mean, some space that we are trying to explore as well is when it comes to automation and mechanisms for managing keys that are not necessarily just that you migrate everything to PQC or whatever. And for example, we are extremely interested in, and we are making some experiments with an ITF called. Sorry. Oh, yeah. No, it was probably I was talking too loud. This is we are experimenting with something that we find very promising, like is mechanisms for automating key management, like for example dealing with I don't remember from my it's called it was with the work of a group in the ITF called I2NSF, and another one that is called ACME that is about certificate management, another like trying to solve if you have some environment in which you cannot make the migration for whatever the reason, then well you try to find mitigations for that. Something, and you think about it, is something similar to what happens, well, it's still happening with IPv4 and IPv6. There are enormous zones of the network that are not willing, for whatever the reason, to migrate to IPv6, but you find a way in which they can interoperate and survive and deal with all the limitations. Apart from that, I believe there is another risk in the direction, and it's about the right balance between standards and regulation. I mean, in the recent days, we have witnessing a struggle for standardizing many times, standardizing too soon. I mean, when talking about standardizing, it's not like the process for selecting the proper algorithm. That this is something that has to be standardized, let's say, from the roots. But in other cases, in general, bodies run very fast to occupy the space and say, no, we have the first standards doing X, Y, or Z. And even worse is when you witness regulation in advance. You cannot make proper regulation, or you cannot make something that is a useful regulation if you don't have sound technical standards. Because otherwise you're regulating just in terms of wishfulness. It's like I remember we had in Spain, the first constitution we had mandated that all Spaniards should be honest and pious. Say, yeah, well, fine. How do you measure that? And some of these regulations is early regulations. And to give you an example, recently I was in a meeting in which the European Union was presenting their AI regulation. To me, it's a little bit premature. We don't have the standards yet. Let the standards happen, and then don't oversize standards. And finally, if I may, is about diversity. Something that concerns very much, I guess, a raise of hands, who here remembers the Heartbleed attack? Heartbleed was a very serious. If we go a monoculture of PQC, we are risking another Heartbleed. Another direction that we are opening, we are trying to foster companies, small companies, trying to play with agile hardware and software implementations of the algorithms that are not necessarily mainstream. Somebody would call that, oh, you're going to commit the worst thing in these days, that is fragmentation. But diversity is not fragmentation. Diversity is a smart strategy to make things happen. The important thing is interoperability. That is another challenge, etc.
So resilience and interoperability.
By means of diversity, yes.
And are you getting the buy-in from senior leadership at Telefonica to make these changes prior to regulation being put in place?
We have started with convincing our boss, that is the CTO. He is on board, so yes, we are moving in that direction. So I would say we started 2 years ago, and we started, you had to bang a lot of heads to make the message, to make them aware. But right now, in the let's say the technical, we have a CTIO, so we don't have to convince the CIO as well. So it's the same guy, and that's in that respect, he's in full agreement, and we are moving ahead with this.
Okay. Okay. So you see the role of the CTO. Luke, I hope you feel the true weight of responsibility of your CTO role at Vodafone. Ryuji, I'd love to come back a bit on the business opportunities. So we've talked again about some of the challenges, the sheer scale of the networks, but are there business opportunities that can be passed on to the customer? I mean, what we see is that there are entire sectors. There's the financial sector, there's the government sector, there's the utility sector. I mean, if the experts in this room are having challenges managing the migration to PQC, we can imagine some of the challenges going on, particularly in the smaller enterprises. Think of the SMEs. I mean, the SMEs are the heartblood of much of the economy of much of Europe. I mean, how are they going to manage? So I think the telco has a role in providing a secure infrastructure, and it is definitely in pretty much every country classed as critical infrastructure for its support role, not just for communications, but also for all of the businesses. So what are you seeing, and where do you see the opportunities, and what are you seeing in reality at the moment?
Okay. Well, we are working, try to run the several proof of concept, like experimentation with the enterprise company. And we have a wireline business, wireless business for the enterprise. So the problem is, like, if something security error happen, they call us operators and fix it, and they claim it, but they don't pay money for it. That's a problem. Security is somewhat like a given. They have to pay dollar, spend the money for security. That concept is somewhat mess, and of course, laptop anti-virus security software. These are kind of like a very usual, but for protecting the network and the entire enterprise network, that's a kind of like a very gray zone. Whose responsibility is operators or customer? So that's kind of like a communication we have, but most of the time, we discuss, negotiate with enterprise is mostly IT divisions. For them, a network is black box, basically. You guys bring the fiber, and they deal with all the server. So I think we still need a little bit time. We learn from the customer, we educate the customer, and I think the whole industry really move in the directions in the PQC. But at this moment, we are not a volunteering company. We need business for PQC. Otherwise, we cannot really invest to this technology. So that's one struggling point. And one of the message I repeated here from the customer is, security is going to be vulnerable after quantum is ready. But they always ask me, well, government, they're supposed to be most secure infrastructure they need, but they don't use the PQC. Why me? That's the answer I often got. So I think there is some order, right? And I think that once these a government or a big player adopt the PQC, then enterprise and maybe consumer, there's some order we have to read.
It's true. There's a lot of finger pointing of who's first, and it reminds me a bit of the Groucho Marx quote, "Follow me, I'm right behind you," where everybody is waiting for the other to do it and take the responsibility. Diego, how do you see this in Telefonica? Are you in the process of extrapolating business cases where having implemented post-quantum or quantum-safe security can drive additional profit margins with your customers, or where the governments or banks or any of your SMEs are coming to you for that?
We are in contact with the big customers, as usual, because we are talking about new technologies, things that require dedicated people there, etc. And so far, there is a strong interest within the big customers of exploring. Then what Ryuji said about whether they are willing to pay an extra or not, this is something that is still under discussion, but at least just willing to run POCs and experimenting with the ideas, etc. For sure. That includes the government, that includes, Even we have a defense division that I'm not allowed to know what they do, but I'm sure that they are going in the same direction. So in general, big corporations and governments, for sure. We have been playing in the first project I was mentioning about that we are exploring about TLS and IPsec. We have managed, for example, to bring a set of people. It's a quite interesting organization that is helping elderly people to learn about dealing with well, in general, the new network services and all the like. And we are making some experiments with them for enhanced services. With this, we are trying to gain some view of how this could be applied in small businesses and all the like. You know, in Spain in particular, the industrial fabric is, I would say, 90-something percent based on SMEs, and there is a quite interesting market for us. That would imply, certainly, and what we have in mind, we are exploring the idea of some kind of managed security mechanisms that would include something like, well, somebody called that the key distribution mesh. But that's a name that is the way in which you can rely on different mechanisms, probably based on PQC chems, based on QKD, based on whatever, to distribute symmetric keys that can be useful for secure mechanisms that don't require end-to-end authentication, or that require intermediate node secure connection without identifying the end. We're playing with this. We believe that this is something that could be provided. Whether we could make extra money from then or become part of our differentiated offering is something that is not in my pay level. I will provide the solution, and then some others will think about how to make money or not.
Okay, so it sounds like there's a dialogue to have with the chief business and strategy officers.
Yeah, with a few of them, yes.
Got it. Looking at it, where do you see the first use cases coming out for the migration? Which are the key use cases? Which are the key customers?
Yeah, good question. But before answering that, I just want to cover this, that one thing that an infant is going to share with an 80 or 90 years old today on the internet is they're all using cryptographic algorithms. As soon as you're being born, your PII will be generated, is being encrypted, and once you die, that PII still is utilizing that. You're using Chrome or you're using Safari, you're still utilizing that. Doesn't matter of the phone. So there's a common denominator here, is that the risk applies to everyone. It doesn't matter being an enterprise or SMB. Now, coming to the use cases, that's a very good point, because we can go ahead and flip the switch on and off, right? It takes forever, and some folks will call it quantum transition. I call it quantum elevation. And the big cases that we have seen usually comes from the financial sector, and then the second one is from the device manufacturing. And both are coming for two different reasons. On the device manufacturing side, they're thinking, because this device is going to last for the next 10 or 15 years, right? Maybe in the cell phone world is not similar. We are changing the phones every single year or an average few years. That being said, some of the devices that are going out there, and 5G has been an accelerator for this due to connectivity, they're going to last for a very long time. So we are seeing the device manufacturers to start implementing PQC inside of devices. Financial sector takes a completely different approach, and I kind of put this equivalent to the medical sector as well, right? Because they're producing so much data that the value of data is so high that they want to make sure that they're switching that, they're changing that switch right away to PQC, and making sure that they're providing that level of encryption for a very long time. Now, telco to me is in a mixture. If you're talking about the device manufacturers for telco, they'll be on the side of device manufacturers where they want to make sure they have PQC in there. Now, you have the challenge of backward compatibility. You know, your iPhone 11's on and running 5G, so you want to make sure you cover them. And if you're not able to have the backward compatibility, then they're deprioritizing that use case due to the market.
Taylor, any vision around that? Key use cases you're seeing?
Yes. So for us, you know, I think we're kind of starting with what we think are the biggest vulnerabilities. So PKI, firmware updates, and secure boot, right? So those are the things that we are going to tackle first, at least with Ericsson, right? And then I see us kind of marrying crypto agility into zero trust and making that an offering, so it's more of a holistic security and solution, and less of one that's just a PQC solution. I just think that's a bit more appetizing, right? So a security manager that kind of does it all.
Actually, I think that's a really interesting point as well that you've just touched on, is how to implement a post-quantum crypto migration together with a natural technology refresh or architecture refresh like zero trust. And that's a whole different panel we should be having on that one. We don't have a lot of time left. I'd love to end on a slightly more visionary note around, I mean, when we say quantum economy, quantum technologies, it encompasses so many things. Yes, there's quantum computing, there's sensors, there's different communication mechanisms. What do you see as, where does quantum play a role in the future of the network, according to you?
All right. Well, first, I really hope we can migrate in less than 10 years, right? I think that's roughly what SHA-1 to SHA-2 was. We can do better, right? So hopefully within 10 years, we do have quantum-resistant networks. I don't know what G that will be, all right? Maybe it's going to be REL 19, and we're looking at 5G Advanced, but that's really what I see. I think just personally, I'd like to see where quantum meets AI, right? Is there quantum computing solutions that can help with AI compute? And will AI kind of progress quantum computing? Can it be utilized in that way? But that's just, me daydreaming. Yeah.
Thank you. Avesta, any last thoughts and vision of quantum in future networks?
Look, it's extremely scary, right? Because there's pros and cons like anything else. Somebody can come up with a quantum computer and break all the bitcoins that we have been mining, and the whole economy could go down. Or someone could come up with a good quantum computer that is stable enough to start modeling cancer cells, get mRNAs in a very quick time. To me, this is all about opportunity as well as partnership. You build the right partnerships in order to achieve those right opportunities and solve the high-value problems that we are all facing. Extending the human lives, making sure that we are getting rid of the proper disease. But none of this is possible if you don't have proper security in place. So PQC migration needs to be in hand.
Diego, quantum networks, quantum radio, quantum sensors, timing.
Quantum on everything. This morning I read a report of something that they call a quantum engine. They are managing to move nanotubes by means of a radiation pressure. Don't ask me what was that, but just... But imagine the nanobots moving around. I believe that the same way that the networks have evolved, absorbing different things. Things about the first internet were modems and thick cable internet, Ethernet. Then become structured Ethernet. They managed to incorporate fibers. They managed to incorporate even mobile networks that were separated. I'm confident that at the end we will converge into a global network that will include quantum pieces whenever they are necessary, required, more efficient, or you name it. And we'll be able to collaborate with the rest. And we will have a better, faster, more safer network. That's it. I mean, we will call out, this is my quantum piece, the same way that we talk, this is my RAN, this is my mobile, this is my fiber. But it will be the network at large.
Be a network that actually works, and nobody will think about the plumbing, hopefully.
Exactly, as usual, as we do right now.
Exactly. Ryuji, last words. I know that you are also looking at quantum computing and different areas around that, potentially even future quantum networks.
Yeah, so from the Softbank perspective, originally, when we started quantum computing, it's kind of maybe not ready, and where is the demands on quantum computing? What's the use case? It's a very a specific use case that quantum computing can deal with today. But the last 12 months, we saw all the AI boom, right? All the semiconductor in the market is so advanced now, right? And we have a whole AI chip, accelerator chip, and and NVIDIA has a great earning call. It's amazing, but there's a demand now, right? AI needs a more computational power, and quantum can do certain role here. And as you said, quantum, if quantum meets AI, that might be, best business for the quantum. And so now we have a demand, and the quantum computing, they are quite significantly advanced every year. And when the timing, really these business come in the market, and where the operator comes in the business, that's we are waiting for. But we look forward to deploying these quantum stuff. And once quantum computer is available, we need a PQC. we need a QKD, and we need a quantum network. So it's all come together.
So you'll be providing services around quantum
I hope so.
computing. Absolutely. Well, only a couple of years, exactly. Well, thank you all so much. I think what we saw here is some of the challenges, definitely. There are technical challenges and opportunities, but also I think the possibility to make some kind of business opportunities out of this, but also the role of the telcos. What is the critical responsibility of the telcos in providing these kind of post-quantum or quantum-safe services, not just internally to their own networks, but also as services to those who cannot, and the enterprises who cannot migrate in the time available. Thank you all so much. I'm going to pass over back to Laurie, I think, and Luke.